Thank you for organizing this, the Demuxed guys. I'm going to talk about decentralizing video streaming, so that's a very vague title. I hope it will be more clear soon. So we started Peer 5 in order to really decentralize the web, and we think that we're too dependent on servers, and we wanted to build something that it is very, very scalable. And we think that actually the internet was supposed to be decentralized from the beginning, and it was. The main problem is that the web is very server-centric. And what does it mean? Basically, every web page that we load today is coming from a server, and there is no other way as developers to build something else. And even more than that, if we look at the tags that we have in web pages, they are very tied to assets that are located in servers. Even the video tag, you specify a URL, and now there are new things, but traditionally that's how most web pages with video tag used to work. I'm not going to say that forget about servers are going to disappear. It's not. The idea here is, what can we do? What ways do we have to switch some of the logic, some of the work that we are doing right now on the server side, and put more and more work to the clients? And why do we want to do that? So for the sake of this session, let's say the other alternative that we have is to deploy 1 million servers that do transcoding, edge caching, everything that is needed for our very cool video website. And we're going to choose strategic places to deploy these servers around the world. And now that's the option that we had. But still, there is motivation to distribute it even further, although we have million servers. The good thing about distributed computing, where you can have some of the functionality in the client, is that you get elasticity. You get the more users that you have, the more capacity that you have, and it's very, very scalable. Now, if we have 1 billion users, then maybe our million servers are not enough. But these users naturally bring more capacity, more scalability to us. We use peer-to-peer to connect between them, then we can create high-quality video service. The problem today is that sometimes companies deploy thousands of servers, and typically they do 4 times more. They deploy 4 times more servers than what they need, just for these huge events, those peak events that are problematic. And it's hard to maintain it, and it's hard to scale it. And the other problem is latency. So we picked those strategic places, but there are other countries where the servers are going to be far away, and the latency is not going to be great everywhere. Other good features of distributed computing is that it's very fault tolerant, and the infrastructure cost is much more economics because we scale with the end users. And 2 other principles that are interesting are how it's propagated to private networks and local networks naturally, and the privacy that sometimes distributed computing can lead. So if we decentralize the way we work, think about Fire Chat, for instance. It is a mesh network that resides wherever people are, and if it's Burning Man or whatever, and maybe the first, the logic comes from a server, but then these nodes are independent and can communicate, and it's very interesting. And it's actually a movement that is happening, regardless of Peer 5. There are a few initiatives. You can look out at redecentralize.org is one of the biggest index site that lists all the projects. Many of them are not really web, like BitTorrent and MadeSafe, that are more like clients that people have to install, and then they enter this mesh network of delivery or giant computation cloud. But I'm going to talk about how we're going to decentralize web video. What can we do to take some of the part that we currently have in the server and move it to the clients? And it's an evolution, not a revolution. It's not that we're replacing web servers now. We can mix and match several aspects of the video workflow and put it in the client side. And these are transcoding, transmuxing, caching, and delivery. And I'm going to talk about each one of them. So I want to talk about cool projects that do that already. Transmuxing and decoding. So the first project is gpack mp4box.js. So it's the little brother of mp4box, which was mentioned earlier. By the way, it was written from the ground. It's not a port. It was written from scratch to do basically transmuxing of MP4 to fragmented MP4. And this is something that you can do in the server side, but it's very interesting to do it in the client side because you don't have to transmux all your library. Let's say you have a huge library of MP4 files that were created 2 years ago, and now you want to have MPEG-dash. You want to use media source extensions. You don't have to refragment this huge library. You can just use MP4 box, and the JavaScript will change those files on the fly to fragmented MP4, and then you can play it with many different dash players. Another cool project from the same group is their HEVC image preview. So maybe we don't have a decoder for HEVC, but we can still, they built a JavaScript library that can decode HEVC and actually show it as a preview, imagine it on the SIG bar and things like that. Just recently announced, also from France, and the 3 first bullets are French people. HLS.js, which is something many people here waited for. Also transmuxing, so you can take HLS and actually play it using media source extensions. The other option was to use Dash, for instance, and take all those HLS media segments and just transmux them to Dash. And HLS.js does that on the fly in JavaScript, works very well. I heard yesterday from Video.js that they also have something like that. So Video.js contrib HLS plugin does that as well, which is very, very cool. So WebRTC is another tool that you can use to encode some of the videos that you have today, that you can use it in your workflow. So for instance, yesterday we discussed, we talked with Twitch. So users can now encode in very high quality, let's say VP9, their streams, and just push it to the server, and you can ingest it in the server, and then that's it. You already have it in very high quality, very good video codecs. So that's another option, and maybe you're saving many cycles now because you don't have to transcode it again to VP9. Broadway.js is a bit unrelated. It's H.264 decoder in JavaScript as well, useful in other use cases. The other aspect is delivery, which is closer to Peer 5. But I want to talk about Veb Torrent first. So that's another very cool project by Feroz. I'm not going to try to pronounce his family name. So Veb Torrent is a very cool concept. It's a mesh network that is using WebRTC data channels. And you can see from the graph there are three types of clients that they have. Basically, it brings BitTorrent to the web. So as a Chrome user, you can consume content directly from BitTorrent. But unfortunately, or fortunately, WebRTC is not compatible with BitTorrent. Different protocol stacks. So they came up with an interesting solution of hybrid clients that translate between WebRTC and BitTorrent. And the result is that you can have very large networks that are, on one end, traditional BitTorrent networks connected to BitTorrent trackers. And on the other end are just web browsers, web sessions that people did not install anything. They just entered some URL, and now they are connected to BitTorrent. And one of the interesting use cases is that you can deliver video over that. You can deliver existing video. As you know, there are huge selection of videos right now on BitTorrent, and it's very, very efficient to deliver it. And now now thanks to Veb Torrent, we can consume it without installing anything. I'm sure there are going to be many interesting projects based on that. Pure 5 is a bit different. Our approach is that we can use existing CDNs, existing servers. That's the HTTP edge you see on the right-hand corner. What we do is we complement existing deliveries. So let's say you're using some CDN and you're using a video player. We're not changing that. We're in between. And instead of using video tag that points to a single server, we manage everything. We intercept all the HTTP requests. We make those requests ourselves to the HTTP edge. And at the same time, we try to optimize and bring as much content as possible from our peer-to-peer mesh network. And by doing that, we can reduce up to 95% of the delivery from the server. So basically, increase the capacity of the servers that you have by 20x. Another interesting use case is in local networks. So we chose to deploy our infrastructure in 1,000 different places, but we cannot deploy our server right here next in this room. But what if all of us wanted to watch a video right now, and it's a conference, it's a webcast of this presentation? We probably don't have, the internet that we're using is not strong enough, or doesn't have enough bandwidth to fulfill all our sessions. So the cool thing about WebRTC and this distributed delivery mechanism is that we're going to help each other within this local network. We're going some of the video segments are going to deliver directly among ourselves, while few streams are going to go all the way outside to the server outside of this local network. This is the most interesting part, though. There are a few use cases that I covered, and very cool projects, and check them out. But I encourage you to think about new ways that we can decentralize our applications. And there are very good building blocks that are, some of them are from just the past few months. Some of them are a bit older. The holy grail for all these apps is media source extensions. Without it, nothing works. Because without media source extensions, you can only tie yourself to a single endpoint, to a single server with the video tag and receive bits from there. Media source extensions gives you the primitives, these very powerful APIs to actually use whatever sources that you want. If you want to take some of the bits from the local cache or WebRTC, WebSocket, whatever you want, you can combine them and then push it to the video tag and gives you, as a developer, a lot of power. Another thing that becomes much more powerful now is binary manipulation. And the web browsers did a lot of work to improve the performance around the array buffer and uint8 array. So basically, you can take a video stream, like the JPEG guys did, manipulate it on the fly in real time, and push it to whatever you want, to a video tag or other peers. And it works fast. Encryption, this is another thing that is crucial in building these applications. So we now have, native encryption in the browser that is useful and works much faster than JavaScript-based implementations that were in the past. Two other cool APIs. So Web Workers is, I'm sure you heard of. So you can take all these heavy computations to a background thread, and it won't affect the actual video rendering. A very cool API that released just, I think, last month is the request idle callback. And so let's say you're doing a lot of computation, a lot of encryption, or you're preparing something. The problem that we used to have is that it's going to load your local resources too much. You're going to consume too much CPU, and then it, at some point, which you don't know exactly, can affect some of the end users. You're going to spin a lot of cycles in the end user machine, and typically you'll see frame drops. And there's a new API called request idle callback that basically call your workers, your callback functions whenever there's in the right time to compute things. So whenever the browser detects that there's free time to compute in the user level, in the application level, it will fire this callback, and that's for us developers, the right time to actually operate. And it improves the performance dramatically. Another API to actually move things from servers to the clients is the service worker. So you can take a request that typically went all the way to the server, intercept it, you'll get also a callback API. And then in JavaScript, you can decide, OK, I want to bring it from the cache, or I'm going to do something else and not go all the way to the server. Maybe I'm offline right now and I can't go to the server. That's something that more developers are being aware of and can do other things. Resource timing API is also useful when you want to actually measure the effectiveness of the server and want to know, OK, maybe the server that I'm working with is much slower than other options that I have. So now, even after you made that request to the server, let's say for Dash, you brought some segment, you can now understand how long it took to fetch that segment, and you can build logic around that, those numbers. So the resource timing API is going to tell you in milliseconds how long it took and other properties about that specific request. Peer-to-peer, obviously. So WebRTC is actually two things. One is the media, with all the media codecs that allows us as developers to upload and ingest high-quality video. This is the main API. There's another API that is this is what we use to build mesh networks in Peer 5. That is the data channels API, which is just arbitrary binary. So you can deliver video on top of it. You can deliver metadata, whatever you want, to build your application. And the last thing is caching and offline storage. The browser vendors give us a lot more space now to actually store content and give us the opportunity to build better offline applications and, of course, distributed applications. With that, I'm going to end, unless there are questions.